we'll be drunk and all of our thumbs went up in the air. Singing in the wind, listen to the thunder rolling over and over. We down, we're getting on fire.
Junior Olympiad in the making. We are looking at this is another STEM communication, Junior Science Olympiad. We are looking at the physics component part 4 in preparation for the Nigerian Junior Science Olympiad competition. We are making reference to past questions from the National Mathematical Center and we have done quite a lot of work. I just want to hand up some past question treatment. Then, hopefully by Wednesday, we try to go into some topics that are very key. So please, you just keep on revising, keep on reading. Success is yours by the grace of God. Now, an object of mass 80 kilograms is pulled on a rough surface. Look at it. There's a rough surface. There's an object that is being pulled. Now, this object is 80 kg. Okay? Okay, 80 kg by a force of 500 newton. So the force that is applied is 500 newton. Find the coefficient of friction. The coefficient of friction, mu. That's the symbol for coefficient of friction. Now, for this object, there is weight component, there is reaction component, R. And this is weight. And weight is mg. Okay? Upward force, downward force. Reaction force always act upwardly. Weight of an object, including your own weight, is always acting downward under gravity, G. Okay? And this G, usually they will not tell you, but you know that it is 10 meters per second squared. Sometimes it will be 9.81 meters per second squared. Acceleration due to gravity. Now, the force applied on this load is connected by this. The force is directly proportional to the reaction. Now, if you remove this, change this to equals to, then you have to introduce the coefficient of friction, this. So this is the formula. But don't forget that this R is everything as this. This R, like where do I write it? Okay, I'm not even written it. R is equals to weight. That means it's equals to mg. So you are looking for the coefficient of friction. This mu, this symbol. So if you make this subject of the formula, mu will be F over R, dividing both sides by R to give you the coefficient of friction. So let me see the question. It says find the coefficient of static friction. A 0.8, B 0.4, C 1.0, D 0.2. E, none of the above. So let's see whether we'll get the answer. So the force is 500 Newton. R is mg. Okay, that is mass, which is 80 times acceleration to gravity, which is 10. So we have these two zeros, cancel these two zeros. So we have 5 over 8. So let's start to divide that. 5 over 8. 5 here 0 is 50. Here 7 times 8 is 56. So that has to be lower. 6. 6 times 8 is 48. What do we have 2? In 20, that is 2. So approximately 0.6. So there is 0.6, yes, D 0.6 something, okay? 0.6 is there. So that is the answer. So take note of this. That is on friction. Now, another question here now is this. Let's see the question. Now look at the question. The force with which an object is attracted to the earth is called its dash. An object thrown up is attracted to the earth by A, acceleration, B, mass, C, gravity, D, impulse, E, weight is gravity. And that is the gravitational constant, 10. Every object that you go that want to get out of the earth is always being pulled down by this gravitational force. So the answer there is gravity. Now look at this. The motion of smoke particle from a chimney. A chimney is a pipe on top of a structure, the roof of a structure, that let out smoke. You know, smoke move in a funny way, randomly, different direction. Okay? So they're asking you, the motion of a smoke particle from a chimney is a typical, is it circular motion, rotational motion, random motion, oscillatory motion? This is random motion. Random motion means moving in a zigzag manner, no direction. Smoke move that way. Another example of random motion is the Brownian motion of a particle, Brownian motion of water molecules. Okay, it moves in a random motion. There's a production. The first production on physics is on motion, and I treated types of motion. So the type of motion are treated. Go in there. Thank God they are asking questions on that here. Now the next question: the heat from the sun reaches the earth by the process of insulation, precipitation, conduction, convection, radiation. The heat from the sun reaches the earth by the process of radiation. The heat from the sun gets to us by radiation. The one that has to do with solid substance like metals, solid substance, solid material is by conduction. The one that has to do with fluid like water or gases is that one is by convection. Let's look at it. Bring it here. We have the one that is like electromagnetic is radiation. The one that is like solid substance like wire, metal is conduction. The one that has to do with fluid, when I say fluid, I'm talking about liquid or gaseous substance. That one is convection. This one is conduction. But you know the rays of sun from the rays from the sun is electromagnetic in nature. Electromagnetic. So just travel by radiation. So radiation is the correct answer to that question. Okay? Now, the next question. The amount of heat required to raise the temperature of a body, that is thermal capacity. Thermal capacity. Okay? But if the one that is required to raise the temperature of a body, to raise 1 kilogram of a body, it becomes specific heat capacity. Take note of that. Now, no, this question is repeated. Second question say I repeated. I don't know why. Now, the next question. A point beyond which a stress spring does not return to its original length is called the. Now, let me explain that. This is elasticity. I will still treat this. I've taken note of it that it's a topic I needed to treat. Then we have limited time, but we'll still try to see what we can do. Now, if you apply force to an object, it extends in meter, force in Newton. Now, the object starts responding proportionally. Then at the time it starts misbehaving, then come again. Then at the time you get to the peak, then it begins to collapse. Now, from here to here, where we have perfectly straight line, we say that materials obey Hooke's law. That means it is within elastic limits. Elastic limits. Now, from this place where it begins to wobble to this place, it is called plastic limit. But that means as you apply load to an object, it keeps extending. It got a stage, even if you remove the load, it will not go back to its normal size again. At that stage, it has entered the plastic limit. Here, Hooke's law is not obeyed. Hooke's law is not obeyed. Hooke's law says that force is directly proportional to extension. It means as you apply load or force, the materials extend. As this increase, this increase. As this reduce, this also reduce. We call it F is directly proportional to what? E. Now, at this point, we call it yield point. Yield point. Now, if you keep on loading this material, like this spring, they talk about spiral spring. If you keep on loading it, okay, it will get to this point that if you put any additional load on it, then it will tend towards collapse. This is breaking point. This point is breaking point or collapse point. Breaking point or collapse point. This is yield point. Okay? So once a material is being stretched or stressed beyond this point, it cannot come back to its original state any longer. Okay? So this one, they said a point beyond which a stretched spring does not return to its original length is called the breaking point? Breaking point is when it has collapsed. Okay? It's when it has collapsed or failed. Yes. This breaking point is also called failure point. Failure or collapse point. Take note. Okay? So that is not the answer. Now let's see the next option. Elastic limit. This is the elastic limit. So not that one. Spring constant. No, spring constant is when you find the slope of this. Like this equation that I told you that F varies as E. If you change this one to equals to, you introduce a constant. This is called spring constant. This spring constant determines the stiffness, how strong, the stiffness, how stiff a material is. Every material has K, even including your skin, your bone has a stiffness can be determined. It means your resilience, your ability to resist being stressed for a particular unit length. Okay, so the elasticity point, I think here I want to call it the release point, but the actual name is yield point. Then you decide to use that's what I say that is very relevant here, release point. The release point. Okay, now which of the following machine do not apply the lever principle? Is it claw hammer? Is it wheelbarrow? Is it single moving pulley? Is it sugar tongs? Is it nut crackers? Yes, all those ones. It is only the single moving pulley. That one is a pulley system. A pulley system is never a lever, does not operate on lever principle. I'm going to treat machine. But meanwhile, levers are in three classes: first order lever, second order lever, and third order lever. Let me explain that. Now, for first order lever, you have the support, the fulcrum, then you have the load L, and you have the effort E. So the fulcrum is at the middle. That is first order lever. Now, for second order lever, the load is at the middle, while the fulcrum and the effort is at the extreme end. That is second order lever. This is first. Take note of the other, second. Now, the third order lever, we have the effort at the center, then the fulcrum and the load at the extreme end. That is third order lever. Please go and Google this lever. Read about the theory and you'll be able to give an example. All these wheelbarrow, claw hammer, nut crackers to know under which they fall into. Now, the last question here. A temperature of 20 degrees Celsius is the same as dash 36 degrees Fahrenheit, 68 Fahrenheit, 11 this, and so on and so forth. So this one, we have degrees Celsius. That is 100 degrees Celsius, 0 degrees Celsius. In Fahrenheit, this is 212 and this is 32. I've taught this in one of these video productions. Degree Fahrenheit. So these are the boiling point and these are the freezing point. Now they now give you one that is 20 degrees Celsius. That you should convert it to degree Fahrenheit. You put y here. So to solve this, you are looking for y. You just interpolate. Interpolation means going in a particular consistent direction to make an unknown appear in an equation. So like this one now, we just say 100 minus 20 over 20 minus 0. Then I will go the same order here. 212 minus y over what? Y minus 32. This is 80 over 20 equals to 212 minus y over y minus 32. You constantly fly. If you do, please bring it here. We have 80 into y minus 32 being equals to 20 into 212 minus y. You open the brackets, you collect lifetime, and you solve this. You will definitely get your answer. Thank you very much for this. Let's see if before you have the exam, we're going to have more of video production. Meanwhile, all the ones that we have produced, we'll try to go to and sit down to see how we can upload them to the YouTube. Just keep on practicing. Thank you.